Hey everybody, I just want to go over some of the most common Chapter 8 errors that I saw. One was just a simple error. When you do your hypothesis for a proportion, make sure you use P for proportion and not the mean symbol. And make sure you put in as your number the national average, not the average that your sample was. So that's for the null and alternative hypothesis. The next mistake that I saw a lot was the type 1 and type 2 error. A lot of you guys said reject the null, but it was true, but you didn't give the consequence. So to help with this one, actually write out what the hypothesis is. And I said Joey thinks the true means 74, but the friend thinks he's wrong. So even label your null hypothesis Joey and friend. So the consequence would be if we reject the null, we're rejecting Joey and accepting the friend. So that means Joey lost $20, but he was right. Type 2 error is just the complete opposite. You'd fail to reject the null. Failing to reject the null is like accepting Joey, but he was actually wrong. So Joey won the $20 unfairly. So these things about Joey are the actual consequences. Let's talk about confidence intervals and how you use those to decide if you reject the null or not. So an example I have here with the 56, my null is that it equals 56 and the alternative is not equal to 56. Here is the confidence interval, 52 to 60. So think of, do you think you can reject 56? 56 is in between 52 and 60. It falls in the confidence interval. So no, 56 would not be rejected. 56, think of it as valid. So if you don't reject the 56, that's like saying fail to reject the null. Okay, so you kind of look and see if 56 lies in there. It's a little bit more tricky if you're comparing two proportions or two means. But if this is my alternative hypothesis, proportion 1 is greater than proportion 2. Let's see what happens here. So if we have a 0.16 and 0.25, this is telling you P1 is 0.16 to 0.25 higher than P2. P1 is 16% to 25% higher. Okay, that higher, that's agreeing with the H1. So if you agree with the H1, that means you reject the HO. I know you guys all can fix is what happens when you get a really small p-value. A p-value is always between 0 and 1. There's no such thing as a p-value of 1.7. So you got to make sure you're looking at your calculator. If it has that e-6, it means you need to move this decimal 6 places to the left. That really means it's a really small p-value. So that means you would reject the null. So don't ever label a p-value as like a number higher than 1 because that does not even make sense. Hope this helps you guys in studying for Chapter 8. All right, this short video is going to help you decide the difference between a matched pair test and a two-sample t-test. So from the Stats Olympics, if we're trying to determine if trial 2 is faster than trial 1, here's just some examples of some numbers of 3 different students. It doesn't make sense to just group all the trial 1s together and all the trial 2s together because that doesn't really tell you if trial 1's faster than trial 2. The only way that determines that is to look at each pair of data individually. So this person was trial 1 or trial 2 faster. Trial 2 is faster. It only took them 11 seconds. This is the way that I subtracted it for you on the spreadsheet. So trial 1 minus trial 2 is 4 seconds. And I'm going to put a star by that because that person was 4 seconds faster. This person was actually 2 seconds slower, a -2. This person, the time did not change at all. So if we're trying to answer the question if trial's 2 faster than trial 1, we want to get positive answers when we subtract. So to write our, well, here's the data, and I did this for you guys on the spreadsheet. So I emailed you, I have a tab here that says look here for stats. This is where I calculated the means and the, oh, sorry, this isn't the right one. Let me scroll down here. That's for the 2 sample test we're going to do in a second. Right here. This is where I show all of trial 1, all of trial 2, and here I subtracted them for you, and this right here is the data that we're going to use. Okay, that was supposed to be a hint for you too to use a matched pair here. So here's our data for our hypothesis for a matched pair. We're interested in this in the differences column. These are called differences because we subtract. If the person did not change at all, it's going to be a 0. But we want to see if they improved, which is actually a positive number. Like this person who went from a 15 to 11, they improved by 4 seconds. That's a positive number. That's how you decide what to set here. then all you do is you just type these into your calculator, and you use just a regular t-test. So go over to test, t-test, and we're going to enter stats. Our null hypothesis is 0. Our x-bar, 1.36. Our S, 1.77. Our N is 50. And we want to do a greater than, because that's our alternative, is greater than 0. And I just go down to calculate. And look at that p-value. Again, 8.6 is not a p-value. It's times e to the negative 7. So your test statistic, I had some questions. What's a test statistic? It's just your t-value. So 5.43. And our p-value, you can write it two ways. You can write 0.000. You can write 8.6 e negative 7. Okay, but just know that's really, really small. So our conclusion is to reject the null. And if we reject the null, a lot of you guys said the difference is greater than 0, but actually answer the question, okay? The true average trial 2 is faster than trial 1. Some of you guys were saying is higher. It's not higher. It's faster. Remember, faster means you're taking less time to do trial 2 than to do trial 1. Okay, and then a 2-sample t-test is if you have 2 totally different groups of people. 3rd period and 7th period are different groups of people. So you would want to use a 2-sample t-test. And I think you guys know how to do these in your calculator. You would just enter this information in your calculator, and here's your hypothesis. The conclusion that we found was the 2 classes' average times are not significantly different.